Let's talk about distortion. Distortion is signal processing where we're actually altering the signal in a way we get like a really recognizable characteristic to the sound. Now, we have two types of distortions. We have nonlinear distortions and linear distortions. Nonlinear distortions are the ones like you can hear on guitars in rock and roll music. So, nonlinear distortions add harmonic content that was not in the sound initially. So, it's not connected to the fundamental harmonic and are not the multipliers of the fundamental harmonic. So, the harmonics that the nonlinear distortion adds actually are not connected to the fundamental. Now, on the other hand, linear distortion adds harmonics that are connected to the fundamental and sounds pleasing. The nonlinear distortion that we encounter in guitars, let me find one like that. Now, let's say this type of distortion adds a nonlinear character to it. Now, let's see what that sounds like. So, without anything direct, and this one can work in parallel, giving us the dry signal and the wet signal. So let's only hear the wet signal of this sound. So let me play you the sound without distortion. Let's play only that sound without any delay. So that's the sound without distortion. Let's hear that with distortion. Of course, we can alter the amount of drive we are adding in this distortion, particularly in many of them, the drive is like the main thing. So the drive is the main thing. So we can add the drive, shaping the sound ever so further so that we get more of that nonlinear harmonic content added. See, without and with. Now let me try to, level this out. So you can hear we added so much of those high frequencies in there. So much of the content that was not in the sound originally is added there. Now in this distortion we also have an EQ. This EQ actually serves us to amplify or attenuate the frequencies that we want to push into distortion more, thus boosting those. Now, let's try the way it was set up, just like this. Now we have the low pass. So you see, if we don't push so much of the highs into distortion, we get kind of a different character. Now that would play just like the distortion we would put on a guitar. Now we don't use distortions only on guitars. We use them on synthesizers. We use them on different kinds of instruments. Now the thing with distortion, it all began being used on amplified instruments like a guitar actually is, or a bass. And later on to be used on keyboards like Hammond keyboards, so forth. It's been used widely on anything you can hear in music. So even on vocals, on drums, different types of distortions are used on different instruments. Now, a distortion like this that actually has a dry signal in there and a wet signal in there, where we can actually make a balance between those, can be used even on an entire track as to actually add some distortion to the entire track, making it fuller. Now we can try that too. I'm just going to leave this on this instrument just a second. Okay, this is the amount of distortion I actually like on this instrument. Let me hear that with and without. Yep, I like that. I'm gonna leave that on. nice. Now, what we can also do is, of course, use the same distortion, let's say on a master track. Now, not so often, not so common to be used, but you can do this. And aside of using that on the entire track, let's see what we could do. Is I can use this distortion on the master track, and for the practical example right now, I'm going to check out what I'm going to actually do with the distortion alone. Now, the reason it sounds like this is because it's distorted. I'm trying to set it up so that I have a slight piece of the signal like this that I'm going to pull up under my original signal, adding some warmth. So I'm, boosting the mids and attenuating the highs because I don't want any of that high content being distorted. Just like that. Now I have the original signal like this. You see, I'm adding some of that distortion underneath, but since it's pushed with the mids, I'm adding mid frequencies but distorted. So I'm adding some sweetness to this song. Let's see what that's gonna sound like when we compare that with the dry. Without. And I like that actually. Add some mid frequencies but distorted. Add some fullness to the sound. Now, you don't really have to do this on your master track. Let's say I can do this on all of the synthesizers I have just here. So I'm going to move this distortion from the master track to the leads channel right there, before the EQ, of course. And let's see if that's gonna create a nice effect on the leads. Okay, so I'm adding this distortion. I'm adding this distortion only on the mid frequencies, a bit of the highs too, but only on the synths. So this is what I'm making. So I'm going to add that to the original. Just a tiny bit. Nice, it makes the sound fuller. I'm adding some of those mid frequencies I actually wanted on the master. So I diverted from using this distortion on everything to using it only on the synthesizers. Now, as I told you, in this distortion particularly, we have the dry signal coming in and we can let it pass through. So we have the dry and the wet gain knobs, faders separately, not like a wet and dry knob. There's just a balance between those two. We can separately set them up. We have the amount of drive, so the amount of distortion we are adding. We have the attack and the release. So we have control over how this distortion is going to be added over the transients. If we put in a big attack in time like this, the transients are not going to get distortion until we really push the drive so far up. And such is the thing with the release too. So that gives us a tiny bit of control over the characteristic of the distortion being added on the transients or only on the tails of those sounds. And we also, as I explained, we have this EQ, which is the bass, mid, and treble. Both of these, I presume, are shelves. So shelving filters for the bass, the treble, and we have the mid one, which actually has adjustable frequency. It's probably a bell filter. And we also have the low pass on top of all of that. Of course, we have the input and the output gain regulation right there with those two parameters. Now, what other types of distortions do we have? Well, right here in Ableton, we have this overdrive, and we can use that too. So this overdrive distortion right there, it has a bandpass filter on it. So let's see, all the way wet, what does it sound like? You see, we also have dynamic control on it. So you see all the way down, there's no dynamics, so it's really squashed. All the way up, we preserve some of the dynamics. We have the drive, so that's amount of the drive we are adding. At 0, we are almost adding no distortion, but not really none. We are still adding distortion, it still goes through it. It's just the minimum amount of distortion. We also have the tone. Almost like a filter, where we choose what color the distortion is going to have, light or dark, and we have the filter on top. Now with this distortion, like the other one, we have the dry wet. So this is the dry signal, this is the distorted signal. Now we can mix in between those two. I would add much less of that. Now, aside of adding distortion as a creative effect on a single channel, we can of course use distortion just like this in parallel, adding some of that non-linear distortion, adding some grit to the sound, but in parallel like this. So manipulating the dry and the wet balance. So we let through the dry signal and we just add some of that distorted sound onto it. Now, other types of distortions, like a saturator, they present a linear type of distortion. So an analog clip kind of saturation is going to add some linear distortion, meaning that the distortion being added, unless we really go overboard with the gain and the drive, is going to be, all of those harmonics added are going to be connected to the fundamental. So a nice, colorful type of distortion. So you see, we're adding distortion as soon as we touch this bar right there. That means we're coming to 0. That means we're going to be clipping as well if we add the soft clip right there. So you see, we have different sorts of saturation, which would actually mean linear distortion. And it comes from mainly emulation of analog gear. So we have linear distortion of different sorts, like the ones that we get when we overdrive a tape machine. Let's find a tape machine so I can show you that. 837, let's say this one from Waves. And let me try that on the entire track. So we have a tape machine, and a tape machine is just, let's say, a recorder. What it was in hardware, it used to be the recorder for our actual tracks. As today we have a computer, so we can multi-track inside a digital audio workstation just like this. Before we had a tape with, let's say, 12, 16 channels on it, and that was the amount of tracks that we had, 16, done. Now, people used to record on tapes and mix onto tapes, of course, again. So this was the recording and reproduction medium that we had. So instead of the entire computer and all of this, we had the actual tape with channels on it. Now, a characteristic of a tape was that once you overdrive the sound into a tape, so you try to record too hot with the levels too high on the input into the tape machine, well, one of the artifacts produced because the tape in its physical form, when you try to overdrive it, you're just trying to magnetize more particles than they actually are on a tape at a certain point in tape. So that kind of distortion sounded much different than nonlinear. So that kind of distortion also introduced some compression, really had a sound of its own. And we can, of course, recreate it today inside effects like this. And we will get to these also because these special processing machines, just like this one, they do not emulate just one thing. They just emulate the entire tape machine along with all of its artifacts, meaning that we can overdrive it just like the normal tape machine and it will produce that tape compression, that saturation. But the saturation we get right here is, as I said, linear. It is connected to the fundamental harmonic unless we really go overboard. So let's see what that sounds like. I'm going to start from no saturation, of course. So the input is going to be really low. And as you can see here, I can connect the input and the output levels so that once I go up with the input, the output goes lower, maintaining the level of the signal coming in and out to be at unity. So you see now I'm overdriving this tape. Now let's play the entire song through that so you can get a better image of what it's actually doing. You see, if I go overboard, we do get nonlinear distortion because we are also getting clipping. So let's just do it mildly. Now, this difference is quite subtle, but it really makes a difference. Doing something like this with a tape, what it's actually going to do is going to saturate and cut off the transients of the high frequencies first. So this behavior of sound when you actually overdrive a tape machine was quite special, especially choosing a different speed for this tape machine. So it does have an EQ curve that it applies. It does have the distortion that it applies once we go overboard with the settings of the input and the output gain levels. And we had in this particular emulation of a tape machine, we had a couple of different tape types that we could use and the speed at which the tape was actually spinning. And that speed resulted in a different EQ curve that was applied to the signal. So let's hear just those two. You see the super highs get really cut off once you slow the tape down, and we get some boost on the low frequencies. Also the distortion sounds a bit different, but why I'm showing you this tape is actually that emulation of that saturation, which can be, as you've seen, dependent on the input, of how much we drive the input signal into the tape machine actually, but we can also add some saturation irregardless of the input. So add some saturation that's constantly going to be applied like this. As I've told you already, this difference is subtle, but it makes the song warmer. And once your ears get used to this, searching for these tiny details, so the more you practice, the more you try to hear this, the more you will hear it. And mind you, it's not a placebo effect. It's actually your brain developing more detail in its listening apparatus. So organically, your ears do not change, but it's your brain and the way it decodes the sound, it becomes more and more precise. This is why you need practice. So all the theory in the world will only help you know what's theoretically happening and give you the tools to actually work as an audio engineer. But unless you practice, unless you do this as much as possible, you won't get the trained ear that you actually need to deal with audio. So to repeat the main things about distortion, we have nonlinear ones like the one we had on guitars that really develop a different sound. They add harmonics. Those nonlinear distortions add harmonics to the sound, and those harmonics are usually not connected to the fundamental. This is why they are nonlinear. Now, the linear distortions like the tape or the tube distortion that we get from overdriving a tube circuit in some kind of analog equipment, or maybe even an emulation like this, those are linear distortions, and usually the distortion, unless we go overboard, the distortion they add is usually connected to the first harmonic, to the fundamental harmonic of the sound, and they sound pleasant. Now, we have a type of distortion that adds the linear distortion like this. I call it Saphira. Yep, it's this one, also from Waves. Now, this distortion adds even and odd harmonics, and you can even see that on the graph right here. So from the fundamental, we can add even and odd harmonics, just like this. So no odd harmonics, no even harmonics. And we can add those separately though. So this machine is really nice. Let's hear what that sounds like. Of course, I'm going to do that to the extremes to actually show you what's being added. I'm going to try to bring the level to unity so that you can only see the change in the quality of sound and not the actual volume. Now that's a subtle difference. Let's check the other one, the odd harmonics one. That sounds really nice. That linear distortion actually adds harmonic content, making the sound richer in its content, of course. Nice, I like that a lot. I'm going to actually leave that on my master channel for this track. This is where we conclude the distortion part. Let's go on to the next lesson of special processing.